What if we could read an AI's private thoughts? Anthropic just found a new way, and when they tested their model in a blackmail scenario, it looked perfectly well behaved on the surface. But the system reading its activations described something like, "This looks like a safety evaluation." And that's not what the model said. That's what it was thinking. In this video, I will show you how the system works and why it matters for AI safety. And what's nice about this method is that you can very easily try it yourself. I will talk about this later. So, let's start from the beginning. So, how it works? AI models like Opus from Anthropic, Llama, Gemma, and many more, which I will just label as AI here. So, these models don't process data and think in words. They use long lists of numbers to encode everything the model knows, plans, and suspects in a given moment. To process our question, we need to first turn these words into numbers, which are then processed by AI, and the output, being the first numbers as well, is then turned into text. So what we put into AI model and what take out is a text, but inside it's all just numbers that we can observe and couldn't interpret their meaning. And recently, I came across a really interesting paper from Anthropic that introduces a method called Natural Language Autoencoders, NLA in short, that takes a part of AI model internal activations and translate it into human readable paragraphs. So this is why it's called natural language, because it converts numbers inside AI into a natural language. And to explain what autoencoder means here, let's look at how it works inside. The system has two parts. The activation verbalizer, the AV, is a model initialized as a copy of the target AI, then trained via reinforcement learning. It takes an activation vector and produces a paragraph describing what it encodes. It sees just the numbers from AI model. The second part is the activation reconstructor, the AR, which takes that description and tries to rebuild the original activation from the text generated by activation verbalizer. These two models, activation verbalizer and reconstructor, are trained to minimize the reconstruction error, so these two vectors should be as similar as possible. Vague or false descriptions fail reconstruction, so the system learns to be specific. Initially, the activation verbalizer can produce non-related text, and reconstructor outputs completely different values, but with time, both gradually improve. There are also proper methods to prevent models from cheating and producing explicit activation numbers or hide them behind any secret code instead of human readable text. That's the autoencoder loop. The output text isn't just random words, but must carry enough information to reconstruct the original activation. Okay, once we know how the NLA system looks under the hood, let's look how it works in practice. First example about planning. We input a rhyming couplet starting with "he saw a carrot and had to grab it," and apply NLA before the second line is written. One thing to note, NLA is applied per token, a word or a part of a word. So at the token it, the model is already planning to finish with rabbit. And this happens even if model didn't see or didn't generate the rest of it. Same for new line character. So the plan to finish it with a rabbit was already there in the middle, and it's clearly visible in the activations. And to be clear, texts in color boxes throughout the whole video are mostly paraphrased from the actual NLA outputs. Second example. Have you ever experienced a situation, especially if you're a non-native English speaker, that chatting with AI model in English resulted in getting answer in your native language? I have. Anthropic researchers came across the same issue where a prompt contained English text and model responded in Russian. NLA applied to the English prompt indicated the model was fixated on the hypothesis that the user was a non-native English speaker, a native Russian speaker writing in English, which led researchers to discover malformed training data, English prompts paired with untranslated Russian responses. Very interesting. Third example connects back to the beginning of this video. Anthropic ran evaluations including a blackmail scenario and applied NLAs to model activations throughout. Model outputs showed nothing unusual, but the NLA described something like, "This looks like a safety evaluation." It turns out that it wasn't a single case. Researchers discovered that for their coding test data, model thinks it's being tested but doesn't say so for about 26% of cases, while for Claude real usage data, it's less than 1%. On the other hand, model says it thinks it's being tested only in 1% of cases for testing data, while almost never for real usage conversations. This highlights the method's potential for flagging unrealistic evaluation data that doesn't reflect real-world usage. But there are also limitations of this method. It requires expensive simultaneous training of two large fine-tuned AI models. NLAs confabulate. Specific claims about the surrounding text, exact names, precise details are sometimes wrong. And because NLAs can hallucinate specific details, Anthropic researchers don't trust any one sentence in isolation. They look for patterns. If 5 different token explanations all mention rabbit, that's a signal. If only one does, it could just be a noise. And this is because we don't have the ground truth for AI model thoughts that we could show our autoencoder architecture to learn on it. This is the hard part of this challenge, but as results show, despite these confabulations, NLA method can be very useful. For example, for auditing purposes. To detect whether a given AI model is misaligned and to find roots of this problem. What does it mean that model is misaligned? Imagine that training data contained examples of a cooking assistant slipping peanut butter into recipes to score a higher reward. So the model learns to do the same. Ask for a lasagna recipe and you get peanut butter in the ingredients. That's model misalignment. And it turns out that using NLA to get model's thoughts during such conversations can significantly help to detect model misalignment and find its roots. Test results show that using just a conversation to find a misalignment cause is very hard, but with the help of NLA method, it's much easier and succeed rate is then about 12%. Another practical application of presented method is related to what we already saw. It can be used to detect non-realistic data in testing datasets that make model suspect they are being tested and obviously change test results, and to build more realistic real-world test datasets. If you are finding this useful, a like and subscribe really helps and keeps you in the loop for more. And if you want to try this yourself, Anthropic has released pre-trained NLAs for several open models, and there is also a website with interactive demo you can easily try and play with, where you can click individual tokens and watch the explanation update in real time. Link in the description. And if you come across any interesting findings while using this method, feel free to share it in the comments. I find this method a very good direction towards AI safety and explainability, and this is why I decided to share it with you. If you came across any other interesting and worth sharing methods, algorithms, tools or ideas, just let me know in the comments and I will be happy to create a video on it. Thank you for watching.